As complicated as normal distribution problems can look and as different as they can look from each other, at their heart, there's really only two types of normal distribution problems, and it all comes from the fact that Table A is a conversion table. The z-scores are on the outside, the proportion below those z-scores are on the inside. And so you're either converting from something that comes from the inside and going to the outside, or something from the outside that's going to the inside. So let's take a specific look at these two types of problems. So the first type would be going from some kind of raw score to the percent below or above that raw score. The raw score might be ACT test points, or it might be inches, height in inches, or it could be number of countries visited, or it could be even a percent. It could be percent of women in the workforce. That raw score could be many different things, but essentially you're asking whatever that raw score is, we want the percent of the distribution that's either below or above that given raw score. If we have this type of normal distribution process, there's three steps we'd want to do. Step one would be drawing a picture. And on that picture, you'd label the raw score or cutoff value, whatever it may be in the context of the problem, and then shade in the proportion you want. In other words, do you want the proportion to the left or below? Or do you want the proportion to the right, which would be above? Step two, you're going to use the fact that you have the raw score value, so that's an x value, and you should be given the mean and standard deviation of your distribution to know what you're working with. So you can use those three to calculate your z, which you can then, in step three, look up in Table A. So you have the z-score, you have what's on the outside. Use that to find the portion of the distribution that's below that given z-score. If you would need the portion above the z-score, you just subtract whatever number you find in Table A from 1. That would give you the portion to the right instead of to the left. And then either way, whether you got to the left or to the right, you can multiply that number by 100 to convert the portion to a percent. So let's take a look at that. ACT is a college entrance exam score, and let's say that scores follow a normal 21.5 distribution. What percent of ACT test takers score below a 27? First of all, let's decipher some of the stuff here. So when we see this notation, the N stands for a normal distribution. The first number will be our mean, or mu, if you're looking at the formulas, and the second number will be our standard deviation, or sigma. This number here would be an example of a raw score or a cutoff. We want the portion below, although we could find the portion above with almost an identical process. We would just have to subtract our percent from 100%. So step one, let's draw it. So we have our normal distribution. Our particular mean is 21, so we'll put that right in the center. And we're looking at this raw score of 27, which you don't need to get it exact, but do get it to the right of the 21 because it is higher than 21. And we want the portion below. We want to know what percent of this normal distribution is sitting below 27. So in step two, we're not going to be able to look up a 27 in Table A. We need to convert that to a z-score before we can use Table A. So we're using this formula here and plugging in the values for our raw score, our mean, and our standard deviation. We get a z-score of 1.20. We can then use Table A to figure out what portion of a distribution of a standard normal would be below a z-score of 1.20. So we're looking for a z-score of, we have a z-score of 1.20, which means we have the information in the margins here. 1.2, so we get our first two numbers there. And then the 0, the 100th digit, we're pulling off of the top here. So 1.2, and then the 0 would give us a value of 0.8849. In other words, 88.49% of ACT test takers score below a 27. So this portion right here is 88.49% of the distribution. So if we wanted the percent above a 27, and we know that there's 88.49% below, we would just take 100% minus that here. Now that's not accounting for the portion that do score exactly a 27, and getting into that requires a little more specific terminology, but for now we can just say that 100% is either below or above that particular cutoff, and that'll give us a estimate that's really good. Now the other type of problem would be when you're going from a percent below above a raw score to the cutoff or the raw score itself. So if you're doing this, your step one is still draw a picture, except now you're showing the percent. If you're given the percent to the right of the cutoff, you can go ahead and write that on your drawing, but then subtract that from 100 so that you can write the percent on the left. Convert this to a decimal by dividing by 100, and this is known as a cumulative proportion. It's the portion of the normal distribution that's below whatever mystery z-score it is that you're seeking. So to find that mystery z-score, then in step 2, use table A to find the proportion. So now you're looking in the body of table A. Once you find as close as you can, you'll be in between two numbers. You'll trace it to the outside of table A to get your z-score. Once you have your z-score, you'll move down to step 3. You'll plug the z-score in here. The mean and the standard deviation you should be given already, and then you can solve for x, which is that raw score cutoff that you were looking for. So let's take a look at how we would do that. Again, we have ACT scores, normal distribution, mean 21, standard deviation of 5. But now our question's a little different. We don't have a specific raw score yet, or cutoff. We want to know what cutoff or what raw score would you have to get in order to be in the top 5% of all ACT test takers. So step 1 again is draw it. So let's get our normal distribution there. And now instead of having a specific cutoff, we don't know the value of this like we did in the first type of problem, but we do know that we want the cutoff that would give us that top 5%. Unfortunately, table A only gives you the portion to the left of a cutoff, so we need to figure out what portion of the graph this is, and to do that we would subtract from 100%. There's 100% total, and we know 5% is tucked up here in the top 5%. 100% minus 5% will give us that 95%. And again, just to rephrase the question, we're looking for this mystery value that will separate out the bottom 95% from the top 5%. So step 2, we need to use table A to find the z-score. Again, in order to use table A, we need the percent below our cutoff, which is why we had to subtract this value from 100. If we had tried to look up 5% in the table, it would have given us something similar to what we need, but not quite exactly. What we really want is taking this number 95%, change that to a decimal, which would give us 0.95, and then let's take a look at table A. So now we have the portion to the left. In other words, what we have is located down here. What we're trying to find is in the margin. So we're looking through here for 0.95. You usually will not find it exactly. It'll usually be between two values. It's a little messier than when you're looking up the z-scores. And once you find which two it's between, you trace that to the left to give you the first two decimals of your z-score, and then up to the top to give you your final one. So our answer here is 1.64 or 1.65. Either one is fine. When we use technology, we'll get a slightly more precise answer, but in this case, either one will work. Okay, so we have a z-score of 1.64 or 1.65. That pushes us on to step 3, where we can now use the formula same formula that we used in the first type of problems, except now we're using it a bit later in the process. And we have the z value. You could put either a 1.64 or a 1.65 there. We also have the mean and the standard deviation. What we don't have is that raw score cutoff right there. So we solved this equation. How would we do that? If we multiply both sides by 5, that would get rid of this denominator here. This number would be multiplied by 5 also. We would then add 21 to both sides to isolate the x, and we should end up with x equals 29.25. So in plain English, our answer, we'd need to get at least a 29.25. So this would be the cutoff value. Of course, if you get higher than a 29.25, you're also in the top 5%, but you have to get at least a 29.25%.